Check, check. Check. Can you hear me? Yeah. Okay, so we got sound. It's hilarious. Okay, I'm turning screen share on. Going back to the presentation. Okay.
Hi everyone, my name is Felipe Gasper. I run a consulting business. Based in Houston, and so I can today I'm going to talk about WebSockets and talk about implementation over the past year. I wanted to get that WebSocket implementation. I think it's cool and better. If you're tuning in, you probably know what the WebSocket is. It's a messaging protocol between the browser and the server. So you can do TCP, you can do directly in the browser. It's been standardized since 2001. Not as widespread of an option as all the major browsers. But if you based on customers, so a lot of these major services account. There was a piece of one under that. Going through just use in my spare time. Yeah, WebSocket saves significantly on some design complexity solutions like local service sentiments. So the kinds of applications this could be used for, obviously, search rules. We don't have to search all that far. Kind of a classic WebSocket demonstration is a external paper browser. Games is obviously a very useful technology for system monitoring. Especially if you have places like I have not heard of this being used, but you know what the SCTP protocol is. It's kind of been billed as a successor to TCP. Right, to TCP. Nobody uses it because Windows isn't supported. Yeah, all the good operating systems have it, but it's not. So, and yeah, and those are kind of classic applications. I still feel like this is a potential. The idea of fully integrating server browser could expose any server to where it's going to put your data on all sorts of cool things. And I feel like it's just waiting for that collapse the first time when you use a web application. Oh my goodness, this for this. So anyway. Several WebSocket solutions on CPAN, surprise, surprise. The most widely used one is also the least helpful because it doesn't actually implement a lot of the basics of the behavior, and it gives you like an object support for previewing. It also so it actually supports versions of the protocol that came from before BC. This was useful 5 years ago. It's not useful in 17. Somebody using some ancient version of Safari, maybe, I don't know. That's pretty much everybody can be accountable to having a standards compliant WebSocket in their browser. So yeah, that's this one. Assumes that you have some other kind of framework that's kind of antithetical to what I was looking for in some WebSocket solution. It's Net WebSocket Server, and this is a neat packaged solution if you want an easy WebSocket server. It's quite simple. It's just doesn't not a whole lot of options, but it's also doesn't give you a lot of power in some of the deeper things. Taking stream message extensions if for some reason you want to use a WebSocket extension like compression. This one we're going to talk about later. This one and protocol actually envisions custom message types as a potential extension, and this doesn't allow you to do that. So if the connection is idle for a while, one side will say, hey, you're still there. The socket server doesn't do that. And then these other solutions, these are tied to Great Big Fleets. And if you like Great Big Fleets and if you're using one, they're wonderful. The same problem persists. You don't have any streaming, you don't have any extensions. Basically, only gives you what the browsers give you, which is an incomplete information of what the protocol is. But it's tied to these big frameworks if you're not using that. Use case is a bit complicated. I work in cPanel in particular. Does any of you use cPanel? Okay. It's a kind of bizarre performance because it's this great big Perl application that is small VPSs, and so anyone who acts on the cPanel code bases knows we're very so no move, no moves, nothing. So we have custom implementations of almost everything. And so I wrote this with an eye to potentially use a case like cPanels, but also just, to my mind, an exercise in what a nice implementation of this would look like. So, oh, it's a web hosting automation platform. So like GoDaddy's a big customer. Use it to manage their servers. Anyway, so back at the ranch. So I set out to design yet another WebSocket module. These are the things I wanted it to do. Unlike a few of the others, I wanted maximum. XS is actually fairly heavy in some environments, and I've actually been on the environment where everything I did was as the user, and you cannot have it either. So it has to be pure Perl. I don't want it to be used in any context where Perl can be used. As an ideal, I want it to be something that exists, all the existing WebSocket modules to actually read and actually save themselves some of the heavy lifting that they're doing. And obviously, I wanted everything the WebSocket protocol. So you have to do a big client and a server. I wanted it to stream. I wanted it to have all those extensions. If you read the protocol, it's the main two ways it has. It's got the three RSP flags and the frames, and then custom frames. And also, we had to be like, if it's going to work in a code base like cPanel, when you have a memory-strained environment, if you play around in Perl's guts, you know that it accepts heavy memory usage in exchange for the ease of use. Is it a string as a number? What's the big difference? Just it's free, right? So anyway, the protocol is designed to divide it into halves. There's a handshake portion of the protocol, and there's a data exchange portion of the protocol. And a handshake is an interesting problem because if you look at it, it's just HTTP handshakes, which is nice because you can reuse your existing HTTP logic, but that also makes it a bit tricky to design a WebSocket implementation if you want to be as light as possible, because that means you can't use any off-the-shelf. You can't use HTTP request, you can't use HTTP response. Things where you just hand the socket to the WebSocket library and does the rest. So this is what that looks like on the client. I won't go into a great deal about this. With the WebSocket key, and then prove that it's an actual WebSocket server. The server has to send the key back transmogrified in a very specific way. So yeah, we can't use these. So when we do this, what it had to be, at least what I came up with, somebody can do it better, is the application is responsible for doing the parsing into a list of key value pairs. And once you have that, then you can hand that off to the handshake logic. So you can use whatever homegrown, whatever your seed module. Once you've done that, then you just hand that off to WebSocket logic, and it will do the rest for you. So you instantiate the handshake client object, you give it these parameters that it's going to work in. Say I'm going to connect this URL. These are the sub-protocols I know how to speak. WebSocket has the concept of a sub-protocol. It's like TCP. It's not really going to end itself. You're probably going to rest some protocol on top of it. Maybe it's AMQP or STUMP or something like that. So the protocol describes a way that the client is running. So that's what that is. And then if you want to set up a server, it's ever so slightly simpler to create a handshake object. But again, because we don't have an interface we can rely on, necessarily we have to expose generic methods. So we validate the method, we validate all as per the RFC specification. The server consumes the headers. And once we've done consuming the headers, then we get back shake string to the client. Now the messaging component of the protocol is one we, especially when we use logic. The most basic element of this is main logic. So the simple and obvious way to do that is BC classes, names, and this is what I didn't see any of the other WebSocket members actually did. They all kind of treated the same kind of thing, and it's actually kind of useful to keep these classes for what it is. The close frames in particular have some extended logic. It's useful to be able to make module. So the framing logic looks like this. You create the frame with the different parameters. Mostly you're going to type in the payload. If you're a WebSocket client, the framework is that you do this XOR masking thing. I read about it one night. It's interesting. There's a weird security problem between it. So, anyway, you read the RFC, it's kind of fun. The guys who wrote this so they're like, we might reduce this. That's how we. Now they do have the big caps that all clients want. If you're doing that, then this is how you make the frame as a client. If you're not a client, then so simply you can just get rid of that. pipe in and then you're done. And if you are one of those special people who are using WebSocket in a context where you in class, maybe you want to do things. Got do that here. You can create your own WebSocket name class as a subclass of NetWebSocket name. Just assign it whatever is, and then the other classes we'll talk about here in a second. They know what. So this is why you don't want to do the framing yourself. It's not quite as bad as it looks. It's just a lot of variables. Well, I suppose 6 different sizes of frame, whether you're masking or not. And a small payload, a medium-sized payload, single message. So anyway, this is what you don't want to do. And so this is what NetWebSocket frame that subclass gives you. And so if you write your WebSocket frame on top of that base class, then you get all of this for free. And it normalizes all this stuff so that you don't have to worry about the particular details of it. Just get a nice clean interface. Open this clean interface. So if you're going to make frames, then you need logic to parse frames out. And so that's what NetWebSocket does. This is not exposed to applications ideally. This is something to get frames. The reason we don't expose that to an application, we'll talk about it. And if you notice, there's this IO frame class on the top. As I was working on this, I realized that it's a common pattern. I was actually working on it at the same time, and they both had this pattern where I have to look for n number of bytes on the wire. Number of bytes wire, I can't do anything. So IO framed, it incorporates just enough logic to do that, and also my write queue can't take that many bytes yet, so I'm only going to write as many as I'm done sending that frame on a callback. So a nice way to have asynchronous and get a next callback so you know exactly when you're done sending that particular frame. You don't have to use IO frames for NetWebSocket, but you do have to have something that implements that. And we're trying for very generic interfaces, not wanting to make as few assumptions as possible about who might have what solutions off the wire. Actually, as I was writing test code for that actually came up. It's one of the modules I integrated with demonstrations. I actually presented a competitor. So that was kind of a moment. So parser is also extensible. So if you have that custom frame class that you want to use either for a new opcode, existing opcode, plug that in, subclass in NetWebSocket parser, and you give it that very special opcode class 3 definition, and then subclass will know how to parse to use your frame class. So the reason we don't hand off raw frames to the application is because the frame itself is not what the application gets. The application actually gets a message. And the message, kind of like in TCP, you can fragment a message. And so you don't want to give the application the incomplete message. If you play with the browser WebSocket implementations, you don't get frames. You only get a complete message. That's actually a bit of a problem for streaming things to a browser because, well, you could crash the browser. Stream too much, and the JavaScript has moved to it. But anyway, this is how the protocol is written. Applications that sit on top of WebSocket will, of course, have to accommodate that. But if you're going to send a streamed message, now if you use the protocol WebSocket or some of the existing implementations, you have to dig deeply and you have to learn how, like, I set this flag here, but I don't set this flag here, and I set the opcode here, but I don't set the opcode here. So some of those details, it's nice not to have to worry about that. So that's what the WebSocket streamer is. Just excuse me, classical interface on top of the logic that you might want to use to stream a message. The code example that's up there shows you a single message that consists of 9 bytes sent in 3 separate frames. Yeah, so you're chunk, and the very last one you do final. And this actually has a destroy handler on it, so that if for some reason you keep sending chunks to the final, you get a nice exception that says, hey, you forgot something. Because, sorry? Well, that would be before you get to WebSocket. That would be TCP. I don't know.
When you do a cool file.
Yeah, all it does is it sets an internal flag on the streamer object, so you can no longer create chunks. You're basically done using it.
You finish your message.
Yeah, and it sets the thin flag. There's a flag on the
network
frames.
Right. Oh
yeah, it sets the flag that says this is the end of the current message.
Right.
The browser or a network or WebSocket client then knows to okay, this much that I'm holding on to now I give it to you. And again, you can have custom frame support here. You just give it whatever custom frame class you want. So the usual case, you're just going to put in text or binary logic. Just if you put in something with a colon, it's going to say, oh, okay, it gave me a fully qualified package name. So that's a custom frame that I'm going to use. I'm not going to use the off-the-shelf text or classes. So kind of wrapping all of that up, the endpoint class does some of the higher level protocol logic. And this is where you get pings. This is where you'll get automatic handling of close if the peer closes the connection or if you want to close the connection. So you don't have to the specifics of what do I do when a ping comes in, because it actually conceals it from you. So this get next message thing, if something comes in on the wire, that just happens. It'll just send the palm silent. I use to delete a message back because there's really no reason to expose things or palms to the client. Browsers don't do that. So the one case where the client does want to worry about that is if the select loop, if I'm waiting for a message, let me send a ping, make sure the other guy is still there. So that logic is also exposed on the endpoint, as is logic for closing. Basically, with this endpoint class and creating frames and streams, you have a mix of WebSocket. Send and receive messages and automatic response. All the time. So extensions are a big reason why I wanted to write WebSocket. I wanted to be able to apply them whenever the protocol has them to offer. If there was some private solution that wanted to do that, it also just seemed like a good exercise in design. Protocol level, what this looks like is, in addition to all of the other WebSocket handshaking stuff, it sends this sec WebSocket extensions header, where it tells you the details of the extensions that the client server will send back. Yes, I recognize that extension. I don't recognize that extension. The client can actually, there's actually a special status code where if the client isn't happy with the extensions the server has offered, the client can actually close the connection, specifically say, no, you didn't have the extension that I wanted. You're not good enough for me. So,
can I ask you about this?
the connection upgrades. Sorry, I took off some of the lines there just to save space, but connection upgrades, that's just part of the regular WebSocket handshake.
Mm-hmm.
Connection upgrade is an HTTP header that I'm taking the HTTP and I'm upgrading to something else.
Okay, that's what it is.
Yeah, it's that is going to be on in every WebSocket handshake, whether there's an extension or not. So. So this is what that's going to look like at the Perl level. You're going to hand in these extension objects. And look at the pod format WebSocket. It describes the interface that those extension object classes have. There are 4 methods. It has to obviously say what the token name is. It has to be able to represent its internal configuration as a handshake extension object. Again, that's described in the WebSocket pod exactly how that works. There's a consume headers method. It's analogous to what the main handshake classes use. Themselves have to consume headers and have to say, okay, this came in, so I'm going to configure myself that way. Oh, this came in, that's invalid. I can't work with this, or this is invalid. And then finally, just a simple ability to say, yep, we're good to use this extension. No, this is that. Likewise, the server has to do something similar. So the only extension that is in wide use right now is a compression extension called message deflate. Per-message deflate is an example of what's called a per-message compression extension. It's an actual, so you have net WebSocket extension, and then, if you will, a subclass of a net WebSocket extension is a per-message compression extension. And this is defined as a generic idea that can accommodate any compression algorithm. The only one that is in popular use right now is deflate, but it could potentially accommodate, there are a number of new compression extensions. Those could potentially be designed for you. Anyway, PMCE accommodates all of that. So you could plug in any compression algorithm, and there's a preordained. It's actually kind of a neat design. Anyway, so it works to how the handshake negotiation. One thing it defines is that if you have a fragmented message, the initial frame and only the initial frame uses the RSV1 flag. So you can still use RSV2 or 3 for whatever else, but if you're using compression extensions, RSV1 has to be for compression. So you can actually send, even if you negotiate the compression, you can actually send messages even though actually we've negotiated use of compression, which is actually useful for kernel applications because you're probably going to send one byte at a time as the user is pressing.
Oh, okay. That's
yeah. Yeah. So.
Is that from,
yeah. Yeah. Well, if you deflate, I mean, if you deflate compress 1 byte, you're actually working against yourself.
Yeah, you are.
So, so yeah, per message deflate. If you, I am not a guru of the deflate algorithm, but I read more than I care to implement this. The big thing is that each fin frame, the end of every WebSocket message has to be flushed, because otherwise, that sliding window that does deflate, you're gonna end your message, but the other side isn't gonna actually see it when you need it. Part of WebSocket, when I end the message, they have to get that as soon as possible.
Right.
It can work.
Right.
Otherwise, typing, you won't get anything until you get, whoa. Massive stuff. Finally, like, you can negotiate the sliding window size, and you can also optionally reset your sliding. Somebody who designed this because you're kind of defeating a lot of the gains of the protocol like that. But that does potentially reduce your memory usage. So have that option. If you have a server where you have thousands of concurrents, the difference between a 10-bit window or an 8-bit is significant. So you can fine-tune all of this. I think one or two of the other CPAN WebSocket implementations support per message deflate, but they definitely don't give you this. So again, part of the idea of WebSocket, the protocol itself can do, we want to expose. We want the application to be able to decide what of all of this I'm going to use. Support is kind of spotty. You know, the big guy supports it, so that's good. I don't know if the development version of Safari supports it. Yeah. And the interesting thing is here, the browser can't turn it on. So every WebSocket request from the phone or Firefox is going to request per message decline. Even if you, as the author of the client application, know that it's not all that useful to have the browser exposes no control not to request this. I have mixed feelings about that. I guess it simplifies things, but it seems to me that could still be added to the web browser WebSocket object. Because there are definitely.
So when this
So the handshake for per message deflate. Show you a small example of that earlier. So this is just, here it is again. But this has one of those parameters for the per message deflate. This is just negotiating the maximum size of the server's sliding window. But what's going on here is the client is saying, Mr. Server, I don't want you to send me anything that requires to decompress this. The server says, you're in luck, because I'm only going to use 9 bits to compress my stuff. So, yeah, which is nice, because then the client can say, oh, you're only going to use 9 bits. I can bit of memory usage from that. Save my, what would that be, 16,384 bytes or whatever.
16K.
Yeah, this thing that wants it. And so when we implement this in code, kind of as we did with the handshake, where we have a separate handshake object, and then we send in the headers to the handshake object, well, we have to have a separate deflate configuration object that we feed into the handshake object, and then the handshake object will send the headers into the deflate object. Deflate object will consume. There's a fair amount of shuffling underneath, and this is what took me the longest. All of this took me like I I played around with different ways of doing this. And, while my wife was asleep, I was like, okay, I'm just gonna cut some pearl. Yeah, so yeah, that's how this works. And then, so once you have that configuration, once you've consumed all of your headers, then you query the deflate object. Use the compression or not. So in this particular implementation, what I did was a create data object that creates a separate messaging back and forth. Because the messaging itself, kind of like the protocol in general, the messaging itself has its own set of rules separate from the handshake. So when you want to create a per message message, you're going to pass in the frame type and you're going to pass in the payload that you want to be in that message. And then it's going to create for you. That default create message, it's going to create an unfragmented message for you. So it's actually the frame object, which no wire is exactly the same as the there are actually classes in there socket message, but that's not all that important for what so the interfaces are actually consistent with the frames. But anyway, so yeah, if you have the per message support, and then we're good to go. So streaming, and this is something that again, none of the other CPN WebSocket modules support. So I want to be able to stream, and I want to be able to get it. So you kind of have to read the specification for a little bit to take this out of it. But you only do a flush at the end of a message. You only do a flush on the final message of the final frame of a message. Moreover, you only set the reserve flag that indicates that this is a compressed message on the first frame. So in this example, I've got to create chunk and I've got to create funnel. That first frame, it has the reserve flag that says I am a compressed message. Right. The final frame, though, is what has the one I am the final frame, the message is now done. Or at that point, when you do create final, that's when it says to the deflate object, now I need to finish.
Fund it, okay.
Basically.
So when you're streaming a large file of your video, so you're funding it, and then it's going to be that on the it's going to be send the next.
You can do that, yeah.
Or, and at the end of your final.
Yeah, yeah. I mean, what you can definitely do is if you've got a stream of indeterminate length that you want to send as a single WebSocket message, you can do that and then just send an empty final, and then just send an empty final frame. So
yeah.
But the browser will spool all of it because the interface doesn't expose anything
until you get that
file. Now, anticipating that this might be a problem, I did include a means in that WebSocket to grab frames off the wire. So Perl doesn't necessarily have to do that. I have mixed feelings about that because the protocol really is designed so that the message is parsed as the message. So if you have a problem with that, then probably what you want to do is in your sub protocol, you want to build in logic for that streaming action so that you're not potentially taxing the browser or the server. Yeah. Yeah. So dependencies that all of this required is I went ahead and used module load. I've kind of gone back and forth on this action. It seems a light enough thing, but hey, that could be gotten rid of. Base 64 kind of needs that. You base 64 in shell 1, that basic handshake mechanics of the key and the accept to do some of that one thing. The next two modules are very light. They just come from CPAN and split up a URL and then parsing out HTTP headers. It's not a general HTTP header parsing. It's really, really useful. It does exactly one thing. And so I was like, yeah, that's perfect.
Exactly the reason.
Yeah, yeah. These last two ones are ones that I came up with kind of before this project, but they grew. They didn't grow in size, but they grew with this project. All context. I have a little idiosyncratic thing where if I have a function that's returning a list, I want to call this down. If I'm returning two things, the caller is going to see one thing, or if I'm returning no number of things, then I just have to be expecting one thing. I agree with you, you might disagree, but anyway, WebSocket uses this. But it has caught a number of problems when I plugged it into it, because there was that, oh, I didn't realize I was calling it. Means also.
Okay. It's kind of an assert.
Yeah, that's literally what it is. Because you'll either get the number of things you are going to return with an array, or you're going to get the last thing in the list. That's either of those. Neither of those is probably what you want. So then xtiny is a very small exception class that just is it's meant for projects like this. It's meant to be brought in and used as getting rid of the boilerplate to just have a basic exception object framework. It doesn't do a lot of what exception classes CPAN modules do, but that's kind of its virtue. It doesn't thing. It does use overload.pm. I think that's a useful trade-off, because if you get an exception, it propagates it. See what it is.
Cool.
Oh, at the end of all this, I kind of stood back and said, well, yeah, it supports the full standard, automates heartbeat responses and close, so it takes care of a lot of the internal plumbing. You get full extension support, maybe more than will ever be actually useful. And you can do streaming, which definitely has applications. Unfortunately, it's a non-trivial interface. It's not as simple as some of the other solutions, and it's kind of late to the party. There were already a number of other WebSocket solutions on CPAN that have to be written in Perl using WebSocket already. But it was a useful exercise for me, one that I had a lot of fun with, and I hope it will be useful out there somewhere, which is kind of the point of CPAN. So that's that. Any questions? Sort of. I actually did a lot of it. Oh, you just Chrome did.
That's always the problem with anything.
Yeah.
Problem with the page. In A and B,
Yeah. That was really what intrigued me about the protocol in general. A code.
So what's the application for?
Isn't one? And I.
Oh, and you'll do SSH to that.
You don't even need SSH. You'll.
Oh. Thinking about it from the huh.
You take and you those 4 random lines below.
Alice?
So it's not secure at all. Message count. See. So yeah. The situation is not as 6 years. Use it. For example, WebSocket is the only way to go. So you have to have that.
Right,
on the browser
right.
as soon as possible. CD port.
Yeah. And presumably
Yeah. Yeah.
Yeah.
So that's default.
I mentioned at the beginning.
Actually, can you describe? Can you describe
away. I'm not.
Okay, so it's kind of in
Okay.
so
Yeah.
it's going to open. Facebook's just going to sit there with something to say to the release.
Okay.
So Facebook is going to open and wait. So not only do you have effectively persistent connection, but you constantly have to read. That's
Right.
much.
Yeah.
Devices.
Yeah. And it's pulling the clients through to
Yeah.
I hear you.
Yeah. So it's
Wow.
It's that's what mom uses.
it's not so much a problem now. 6 boxes with this. So
Millions? I think I never finally came with
it has significant. Just inertia.
Yeah.
Infrastructure.
So the
So yeah. To the whole masking thing.
Great. Well, there don't seem to be any clients on the chat channel. And there are no comments from Foco. We're down to 2 viewers. Great.
That was excellent.
Thank you very much. Question about the
Oh yeah.
That's very neat. Next time.
Well, you can designs.
All right. Okay.
This is all around.
They intend to solve it.
Okay, so. I don't necessarily doubt. Say if you get this exception class, this particular thing. So exception classes are a lot. This particular string looks like this because itself. SOL. So exception class, then you've got something that's meant to be text representation, custom for each. So for this error, so I might want to find a list of keywords. It's very, very basic. So do one more. Frames off the screen.
That was 6 bytes.
Yeah.
X number of bytes.
Socket frames is 2 bytes based on those first.
Yes. Right.
In order to have
right.
a full frame.
Well, this is much more like.
Yeah. Well, I mean, it's efficient.
It's very efficient.
So you want to do it. Yeah, socket frame.
Everything else gets the benefit.
Using the protocol.
Yeah.
This WebSockets is kind of
Yeah.
in a way.
Yeah.
Yeah,
Great. One nice thing here too.
Yeah.
So. Yeah. So. Side my own time they're reading. Socket equals whatever. It wants.
Yeah.
SCTP also does that, but
Okay, great.
yeah, sure.
Things up. So here are the slides. Right, I'm going to ask for, talk. 6. Yeah, it's here on the horizon.
Yeah.
To me, I saw
It's
But,
it's very
actionable problems. Yes. Can be solved by process. Oh. Parallel.
it still has the
Stick still has.
rules and the syntax is just bizarre. The catch inside the triangle.
That's interesting.
I'm
A lot of time it was through all of it.
yeah. There are people who actually
Yes, absolutely.
sort of peaking.
Okay, well, I think we've got some, the community.
Well, start. And then somebody says, Problems when you I think one of the big to a series of instructions. So, well, Does any of you play?
Interesting.
Fashionable. Well, it wasn't that.
So it is the days.